Hey guys, what does an engineering major do when he's faced with a project with a lot of deep holes into the unknown? Before he blindly grinds metal away, he buys silicone and he makes a mold of the project. Then he uses that silicone rubber mold to make a 3D model in SolidWorks that can be measured, modified, and virtually ported. I drew 3 solid models of the intake port from the rubber mold. Though they are close, they are not to scale, but they do give a good representation of the changes made during virtual modification. First, the stock intake port, showing the swirl ramp and restrictions. I did not add the rocker bolt bump as it would just be removed later anyways. Second, stage 1. I worked the valve guide boss and blended the bowl. I tried to open the path from entry to valve exit along the roof by moving the ramp a little bit to the left. Finally, stage 2. Stage 2 includes all the mods of stage 1, plus I opened the port up from front to back. Though it looks like a big difference, I made 5 cuts, averaging under 1.5 millimeters material removed. I squared up the port, removing restrictions on entry. I also squared up the transition into the head and blended from the transition to the bowl. Okay, let's look at the stock intake. It does have some restrictions. It has the swirl ramp in the front, and along the intake it actually pinches down where that bolt bump is. I made a drawing, and I split it and sectioned it every 20 millimeters. I went back and measured each area at the section. You can see there are 2 restriction points, one along the intake valve and one along where the swirl ramp is. Those are pretty good numbers. Okay, let's move on to stage 1 modifications. Here's my thinking. Airflow wants to go straight. The roof of the port is 25 millimeters at entry. The short side wall points directly at the center of the valve once you remove the bolt bump. I tried to keep the 25 millimeter path from the entry to the valve by shortening the valve boss ramp a little and moving the point of that ramp a little bit to the left. This is what I'm talking about moving the little ramp over to the side. This black line right here is actually, the pen is drawn on the high part of the rubber model. That's the actual bottom of the aluminum rise that comes up here for the valve boss. Right here is the center of that rise. Okay. Now if you come up here, this black line right here is 25 millimeters off this face. So straight down this edge is 25 millimeters. And if you imagine that coming across here, that would be right there. So what I'm talking about is taking the point of this down to there, flattening this part out, because we're going to cut it down anyway to the top of the valve guide, but bring this at an angle to that 25 line. That'll open up all this, keeping this 25 millimeter path all the way past the valve and out. And then on this side, I'm actually going to come around and go up that way. So the airflow is going to go around and then out the valve, kind of making its own swirl. That's what I'm talking about moving it over. I hope that makes more sense. So here's the drawing of that stage 1. Basically the emphasis was on the bowl area. As you can see along the inlet, there really was no improvement. There still is that restriction right there. Past that, the numbers do get better all the way around out to the valve. That was the improvement from doing the bowl cut and blend. Here's stage 2 porting improvements. Basically this is the model. The red part of the model is the stock model, just like the rubber model that I showed you. The clear part is the stage 2 modifications. You can see all the area where it's been opened up. It definitely is a big improvement. The biggest area I took out was about 2.9 millimeters. Most of it averaged between 1 and 1.5 millimeters. So here's an explanation of what I did. This red face right here, I started out and made a line on the face of the cylinder 2 millimeters. I drew another line in 3 inches deep and basically took off material from that 0 line to that 0 line and made it flat. After that, I moved over to this side. I took and drew a line from my cut face, 28 millimeters, and then went inside the port with a measuring device. At the point that it was 28 millimeters, I made a line. That became my 0 remove line. So I went flat between the 2 lines and just straightened it out. Next is this side. It goes from where that cutoff line is up to blend with the bowl and just flattened it out because it had a little bit of an arc to it. So I just flattened that out. Then out here on the face, kind of hard to see, but right there you can see the old line. I made it straight across the bottom. I again went in 3 inches and drew a line and then took material off from this line to that line and made it flat. I took the hump out of the bottom. As far as the top, for the first about 2.5 inches of the arch, I just took out 1 millimeter all the way around and then blended it in. So it's 0 here up to 1 and then 1 across the top. That's all I did to port that intake and clean it up completely to where it's wide open all the way through. Okay, so this is the final drawing. Numbers are phenomenal. The opening starts at 1930. It gradually tapers down. The pinch point, the smallest point inside there is 1584. And then it dumps out of the valve opening at 1641. I did a little math. Again, this is not to scale. This is just nothing but nothing. But I did velocity for the stock port. Ended out from the flow going into that port. There's a net decrease of -3% as it goes through the valve, goes through the port. On the stage 2 port, it actually had an increase of 16%. I'll throw the numbers up. You can play with them how you want, but the test is going to be when we get it done and get it flow tested, how much of an improvement it is over a stock head. I think it's going to be a lot. But thanks for watching, guys. Like and subscribe. If you like this stuff, I'm good at nerding out. So if you have any questions or have any suggestions, please let me know. Thanks, guys.